Hello and welcome. Today, we are going to build from the ground up the single most important skill in mathematics, numerical precision. This is the bedrock, the absolute foundation of confidence you need to crush it, whether you're working on your GCSE, IGCSE, or diving into the IB. So here's our game plan. We're going to start with the why behind our number system. Then we'll get into integers and decimals. After that, we'll tackle the practical stuff, comparing and rounding. And finally, we'll get into a pro-level skill, significant figures, and see why all of this is so crucial for your success. All right, let's kick things off at the very, very beginning. We're talking about the one concept that makes all of modern math even possible. It's something you and I use every single day, probably without even giving it a second thought. So I've got a question for you. What do you think is the single most powerful invention in the history of math? And I'm not talking about some complex thing like calculus. Nope. The answer is actually incredibly simple, but it changed everything. And here it is, the idea of a placeholder, which gave us the number 0. Just think about that for a second. 0 is what allows us to have place value, where a digit's position completely changes its value. It's how we know the difference between, say, 20 and 20,000. It's such a simple concept, but it's the engine that powers our entire number system. Okay, so we've poured the foundation with place value. Now, let's build the first two floors of our structure, integers and decimals. You're about to see how that one core idea helps us make sense of the two main types of numbers you deal with all the time. First up, we've got the integer. You can think of these as the solid, simple bricks in our building. They're just whole numbers, like 5 or -27 or 0 itself. No fractions, no decimals, no messy bits, just straightforward, whole values. And then we have decimals. And this is where place value really starts to show off its power. Decimals let us get super precise by representing parts of a whole number. And a digit's value is all based on how far it is from that tiny little dot, the decimal point. Now this is so important. Let's really break down how to read a number the right way. We don't just say 7452.198. We use place value to give it meaning. It's 7,452 and 1/10, 9/100, 8,000ths. Getting that rhythm down is a huge confidence booster, especially when you're starting out in IB-MYP or working through GCSE content. Okay, with those basics locked in, we can start adding the essential tools to our toolkit. These are the skills you'll be using every single day, not just in your math classes, but in science too. This is the framework for actually using numbers effectively. So how do we actually compare two decimals that look pretty similar? Well, we just go from left to right, one column at a time. Let's look. The ones place, both have a 4. Okay. The 10th place, both have an 8, still the same. But then we get to the hundredths place. We see a 1 versus a 5. And boom, that's it. We know 4.851 is the bigger number. It's a really simple method that can save you from making easy mistakes on exams. And that methodical approach leads us right into rounding. But notice how the instruction changes everything. If we round to the nearest 10, we're looking at the 2 in the ones place. But if we round to the nearest 100, we're looking at the 4 in the tens place. Following the right instruction to get the right level of precision, that can absolutely be the difference between a grade B and a grade A in your GCSE and IGCSE exams. All right, time to level up. We're now moving to a more advanced skill. This is really where you start to separate the good work from the great work, especially for those of you in the IB DP or tackling those higher tier GCSE papers. We're talking about significant figures. You can think of this as the professional language of precision. It's how scientists and mathematicians tell each other how accurate their measurements really are. And here's the key rule to remember. You always start counting from the first digit that isn't 0. So let's use a famous example to see how this works, the speed of light. As you can see, it's a very, very precise number. But what if a question asks us to round it to, let's say, 4 significant figures? Okay, so we start from the very first non-zero digit and we count 4 places. That's 2997. Now we look at the 5th digit, its next door neighbor. It's a 9, and since that's 5 or bigger, we have to round that 4th digit, the 7, up to an 8. Then everything after that just becomes a placeholder 0, and there you have it, 299,800,000. Now for a trickier one that trips people up all the time, 3 significant figures. We count our first 3 digits, 2, 9, 9. The next digit is a 7, so we have to round that last 9 up. But when you round up a 9, it becomes 10, so we have to carry the 1 over, which rounds the next 9 up. It's a chain reaction that gives us 300 million. And here's where it gets really subtle. What about two significant figures? Well, we count our two digits, 2 and 9. The next digit is a 9, so we round up, turning 29 into 30, and we get 300 million again. So what's the difference? It's all about implied accuracy. By writing it to two significant figures, we're basically saying our value is only accurate to the nearest 10 million. In the last example, it was accurate to the nearest million. It's the same number on the page, but it's communicating a different level of precision. And let me tell you, understanding that subtle difference is a huge deal in science and higher-level math. For those of you on the IB-DP track, especially in the Applications and Interpretation course, getting a grip on significant figures is the direct path to understanding more advanced concepts like error bounds. So, we've just built this entire skyscraper of knowledge, right? From the foundation of place value all the way up to the penthouse of significant figures. But the big question is, why? Why does any of this actually matter for you and your grades? Well, this is why it matters. For all you GCSE and IGCSE students, this is how you stop losing those easy marks on calculation questions. For those in the IB-MYP, this is the solid base you absolutely need for the advanced thinking that's just around the corner. And for my IB-DP students, this stuff is non-negotiable. It is essential for getting the accuracy right in your IAs, your lab reports, and your final exams in both math and the sciences. Ultimately, everything we've talked about comes down to this one powerful idea. You simply cannot tackle the big, complex problems if you aren't rock solid on the small, fundamental details. Mastering these basics is what allows you to achieve greatness when you face those grander challenges down the road. So I'm going to leave you with this question. We've gone over place value, rounding, significant figures. What is the one small detail in your mathematical foundation that you are going to strengthen today to get ready for the grand challenges ahead? Thanks so much for joining me.